So we started with, when we very first started talking about quadratics, we talked about the parent function. What was the quadratic parent function? Y equals x squared. That was the function that we said all quadratics parabolas are based off of. Okay? When we look at this picture, we can see all the different things. We can see the vertex, right? The HK. It is a min or a max. This is going to be where our graph changes direction. It is your highest or your lowest point. We have our y-intercept. When we talked about standard form, we said this is the C on standard form. Okay? Buddy points, if we take and we fold our parabola in half along the axis of symmetry, those are the points that match up. We said the vertex does not have a buddy point. So if we're looking at a table, we could find it. Our axis of symmetry, again, splits our equation or our parabola in half, x equals h. We also said if you had an equation, you could do negative b over 2a. If you find your axis of symmetry, you get your x, you can plug it back into your equation and get your y to get your whole vertex. We talked about our mnemonic device, rocks, roots, zeros, x-intercept solutions. Those are going to be our x-intercept values. Remember, sometimes you have two of them, sometimes you have one, sometimes you have none. We have multiple forms of quadratics. We have standard form. That was what we looked at in our last unit, right, where we talked about the C is the y-intercept. We have vertex form where we said insiders lie. For that HK, you can cross out intercept form. That is an algebra 2 thing. Both of these are on your formula chart, okay, which you will have access to in your test, also on STAR. We talked about A, and if you look at your two different types of formulas, you have A on both standard and vertex. If A is positive, it's going to open up. We have a minimum vertex. If A is negative, it opens down. We have a maximum vertex. So the sign of A changes the direction of your parabola. So on graph number 1, I give you a bunch of individual points. Okay? It's going to ask us to complete the table and then look at all the things that we need to be able to find. All of these things are vocabulary. We talked about rocks, axis of symmetry, vertex. If there are already buddy points, mins and max value, as well as what kind of vertex is it, the y-intercept, the opening. We're going to also talk about discrete and continuous domain and range. Most of our examples so far have been continuous. We'll talk about and review discrete, writing the domain and range, and then writing our equation in standard form. Let's start up here and let's make our table. So, do you want us to just go left to right? Does that seem the easiest? What is this coordinate right here? That is the y-intercept. What is the actual, if I'm going to put it in the table, what numbers am I going to put in there? 0, 5. Very nice. And the next one?
1, 0.
1, 0. And the next one? 2, negative 3. And the next one? 3, negative 4. You should see a pattern emerging here. And then 4, negative 3. 5 what? 5, 0. And 6, 6, 5. So you should be able to identify this as quadratic because if you notice, we have those buddy points. What did we say this one is right here that doesn't have a buddy point? What is that going to represent? That is the vertex. Okay? So we can tell a lot from that table. Okay? So let's fill in some of the things we know. Also on the table, we can just label them, right? So right here, 1, 0, and 5, 0. If the y is 0, those are going to be our rocks. So even if you have a table, you can still find these. This one, 0, 5, this is our y-intercept. Okay, when we finally write our equation in standard form, that C should be a 5 because those are related. Okay, so what would you put down here for rocks? We had 2 of them, right? What were they?
1, 0, 5, 0.
1, 0, and 5, 0. Thank you, sir. What about, do you want to do the vertex or you want to do the equation for the axis of symmetry? What do you want to do first? The axis of symmetry. Remember, x equals, because is means equals. So x equals what? X equals 3. Very nice. Remember, it is x equals h on your HK. And that's on their front if you needed to look, or we can write it here. What's my vertex? 3, -4. That's where our graph changes direction. Is it a min or a max? It is a minimum. It's at the bottom. And what is that minimum number? -4. Remember, this is your K, right? It's just the y value. There's no x equals or y equals. It's just the number. Do we have any buddy points? There were several. Do we want to list them all or just maybe one? Which one do you want to list?
2, 3, 5,
2 and what? 2 and -3 matches 4 and -3. So remember what that's saying is that if I take my axis of symmetry here and I folded my parabola in half, those 2 points are going to match up. They're going to be in the same spot. What about my y-intercept? What did we say that was? 0, 5. All these are coordinates, so make sure you write them appropriately. Is it going to open up or down? Up. So this is going to be up. And why is it up? What does that tell us about our A when we get it? Our A is going to be positive. Okay, so when we get to standard form, we should have a positive A. Okay. Continuous or discrete domain and range. Okay, what do you see when you look at this graph? You just see a bunch of what? Dots. Is that discrete or continuous? Discrete. They both start with D. So remember, when we have discrete information, right, they both start with D. We just have dots. That means that we need to list our points. Because when we have the line connecting everything, that's continuous. That's when we use our inequalities. We're saying all the fractions and the decimals and everything in between those nice pretty whole numbers or integers. Okay? So our domain, look at your table we just made. What were all of our x's that we listed? 0, 1, 2, 3, 4, 5. Was it 6? Was that the last one? Okay, that was way, way back, like in Unit 2. It's been a long time since we looked at that, so I wanted to remind you of the differences. The range is our y values. What are our y values? 5 what?
5, 0, -3, -4, -3.
Okay, do we repeat the -3? No, we don't write any repeats, so we're done. Okay. The regression in standard form. Okay, so remember standard form. You can look at the front or we can write it here. AX squared plus BX plus C. We did this yesterday. What do we need to utilize to do this? Could we use our yellow calculator or we could use Desmos? So we can do that and we can make a table in either. If you're going to use the yellow calculator, we talked about menu 416. If you're going to use Desmos, you're going to add your table. And then in that second line, you do y1 squiggle, ax1 squared, don't forget the squared, bx1 plus c. So decide whichever method you want to use. All right, when we put this in, what do we get? Y equals,
X squared.
One-
Minus 6x.
what was it, minus 6 or plus 6?
Minus 6x.
Plus 5.
Plus 5. Oh, look, at our c, does it match our y-intercept?
Yes.
Yes. Our a is positive, it opens up. These are all the things that we talked about.